In this class, we discuss about the transistors. What is the meaning of transistors? Transistor is the device is converted from non-electrical quantity to electrical quantity. That is, non-electrical means let us consider pressure is the non-electrical quantity. The non-electrical quantity is converted to the electrical quantity. The electrical quantity means let us consider voltage, current, like that. So what is the main role of the transistors? The transistor is converted from one energy form to another energy form. So one energy form, that is non-electrical quantity, is converted to another energy means that is the electrical quantity. So let us consider this diagram. So in the transistor, consider three components. First one is the input, second one is the measuring the device, third one is the output. The second part of the measuring the device, that is the signal conditioning or processing the device. So the input device, which is receive the measurement. Measurement means giving the input of physical quantity. The second component of signal conditioning and processing device, let us consider for the filter. Let us consider the filter, amplifier, modulator, then antenna. The third component is the output device, that is the result of the non-electrical quantity or to electrical quantity. Okay, so what is the basic definition of the transistor? Transistor is the device which convert non-electrical quantity into an electrical quantity. The non-electric quantity is the one energy. That energy is converted to electrical quantity of another energy. So the transistor convert from one form of the energy into another form of energy. So the transistor provide an output signal when stimulated by the mechanical or a non-mechanical input. So the physical quantity of the input, whether it is the mechanical part of the quantity or non-mechanical part of the quantity. Okay, so by using the transistor basically consists of two components. The first one is the sensing element, second one is the transduction element. In the sensing element, which is a physical quantity or physical input. Transduction element means that is converted from one energy to another energy of the part. So let us consider this diagram. In the sensing element, we give the non-electrical quantity of the input, and it is the physical quantity, that is rate of change is sensed and responded. What is the main role of sensing element? It is a change from non-electrical quantity to sensing signals. The sensing signal is a response to the input of transduction element. Okay, the sensing signal that is converted from non-electrical signal into a electrical signal. So what is the final output of the transduction element? It is the electrical signal. That is the output of the result. So we give the input of non-electrical quantity, then we will get the electrical quantity of the result. In between the input and output, we have follow two main component. The first one is the sensing element, second one is the transition element. The sensing element is converted from physical quantity to sensing signal. So the sensing signal is converted to electrical quantity or electrical signal. Okay. Let us consider this example of transistors. The first one is the microphone. What is the conversion of microphone? That is, sound is converted to electrical impulse. Let us consider the second example of a light bulb. It is electrical energy is converted to optical energy. The third example of transistor is the electric motor. The electrical motor is converted from electrical that is electricity to mechanical energy. So all the example is converted from one energy to another energy. That is the main role of transistors. What is the aim of the transistors? The transistor is converted from one energy form to another energy form, or a non-electrical quantity to electrical quantity. So the first, basically, the transistors consider two type of transistors. The first one is the active transistors, and the second type is the passive transistors. So the active transistor example is thermoelectric, piezoelectric, photovoltaic, magnetic, then electro infinite, then electromagnetic, then protoelectric, then galvanic. These are the example is active transistors. Then passive transistors with the inductive, capacitive, photoconductive, then magnetic resistancy, thermo resistancy, electrositative, Hall effect, then radioactive, then Aaronic conditions. These are the exam. These are the part considered as passive transistors. Okay. So the first part of the capacitive transistors, the capacitive transistor is the passive transistors. So what is the role of the capacitive transistors? Capacitive transistor is a device. It is converted a non-electrical quantity into an electrical quantity by means of changing in capacitance. Here, the capacitance non-electrical input. Let us consider displacement, force, pressure, flow, level, torque, and etc. The electrical means that is voltage and current. So the capacitive transistors is converted from non-electrical to electrical form. The electrical form is voltage and current. So the principle of the operation of capacitive transistor is based on the equation of the capacitance of the parallel plate capacitor. Let us consider this diagram. Two plate is put in parallel. Okay. So we have put parallel means in between the two plate we have some gap. Okay. That gap is filled dielectric materials. Okay. The gap between the two plate occupied by dielectric materials. So in between the top plate and the bottom plate, it is called D. That is the distance. The distance between top plate and bottom plate. So second part we have considered the length of the plate. Third part we have considered width of the plate. So we have considered three parameters in the capacitance of the transistors. The first one is the distance between the two plates. Second is the length of the plate. Third one is the width of the plate. In between the two plates we have assume dielectric materials. Okay, so in this situations we have using the capacitive transistors formula is C is equal to summation A divided by small d. Here summation, let us assume summation r and summation 0 or epsilon 0 capital A divided by small d. Here summation means it is the permitting of the medium, that is epsilon or epsilon 0 or summation 0. Here epsilon or summation r is the relative permittivity. Epsilon 0 is the permittivity of the full space. The full space mention the value of 8.85 into 10 power minus 12 force by meter. So A is the overlapping area of the plate. D is the distance between the two plates. Okay. So the capacitive transistor C is equal to summation A or epsilon A divided by small d. The capacitive transistors work on the principle of changing of the capacitance, which may be caused by change in the overlapping area capital A, changing the distance d, that is between the two plates, changing in dielectric constant. Dielectric means in between the two plates occupied by dielectric. So the dielectric mentioned by a constant. Okay. So these three changes depends upon the input of the capacitive transistors. So we give the input the physical value. For example, in the displacement physical value or force physical value or pressure physical value or liquid level physical value or flow level physical value. Okay. In between two plates, the dielectric constants change with the help of giving the inputs. Next, the capacitance is measured with bridge circuits. The bridge circuit means that is the impedance, that is X of C. That is the output of the capacitive transistors. So the output based on the capacitance as well as frequency of giving the input of physical quantity. Okay, so the output impedance X of C is equal to 1 divided by 2 by F into C. F means it is the frequency, C is the capacitance. What are the advantages of capacitive transistors? The first point, they have required extremely small force to operate them, and hence they were very useful for use in the small system. The second is they were extremely sensitive. Why it is the sensitive? That is, it depends upon the physical quantities. The third point is the good frequency response. Why it is the good frequency response means all the physical quantity is capacitance, the overlapping of two plates. So equally it is response to the transmitter is the frequency manner. So the frequency of the output is good. The fourth one is the high input impedance, so less loading effect. The impedance, that is the frequency and the capacity is the good one means the output is perfect in the capacitive transistors. But here the input is the high impedance means the loading effect is less. Okay. Then fifth point, the resolution of the order of 2.5 into 10 power minus 3 millimeter can be obtained. The last one is the force requirement is small, so the required small power to operate them. So the capacitive transistors have less amount of the power. The less amount of the power means it is also frequent to the element of the transistors. So the force is also not heavy to the device or in the instrumentation. The next part is the disadvantages of the capacitive transistors. The first one is the metallic part of the transistors must be insulated from each other in order to reduce the effect of the stay capacitance. That meaning is all the capacitance reduce their effect with the help of giving the sensing the element. The sensing element is frequently flow to the physical quantity means that output of the result is frequently getting. So in this manner we have reduced the effect of the stay capacitance in the capacitive transistors. The second one is so non-linear behavior on the account of each effect. What is the meaning of non-linear behavior means? The non-linear behavior is the one type of behavior characteristics in the instrumentation. That behavior is used for positive of transistors. So the ground ring are used to eliminate this effect. The third one is the output impedance is the high on account of their small capacitance value, which lead to loading effect. Suppose when the capacitance is the high value means the loading effect is high. Loading effect is high means the output of the product is not frequency manner. So the output of the impedance is the high means giving the account of their capacitance is the small one. Okay, then only lead to the loading effect. The last one is the cable connecting the transistors to the measuring the point is also a square of the error. Here we studied the type of errors. Lot of error we have studied. Here the square of the error means, suppose in the cable connection from input to device or device to output. Here the cable connection measure which type of input is moved to which type of output through the devices. Suppose device that is the physical quantity measurement set 1 is moved to the output set 5. Suppose the frequency set is not moved to the output set 5 means here the square error will occur. The input of the quantity set properly delivered to the particular output of the measurement, that is the particular output of the measurement device. Okay, then only the cable connecting the transducers properly carry out the measurement of the physical quantity to the system. That is the main role to the instrumentation part. Okay, then application use of the capacitive transistors. They can be used for measurement of the both linear and angular displacement. Here in the transistors normally used in the displacement. In the displacement I have two type, linear displacement and angular displacement. In these capacitive transistors measuring both linear and angular displacement. Okay, here capacitive transistors can measure the extremely small displacement for the particular molecular displacement. Okay, they can be used for the mean of the large displacement up to 30 meter as in aeroplane altimeters. The second one is the capacitive transistors can be used to measure the force and pressure. The force and pressure, whether it is the displacement or changing in the capacitance. Okay. The third application or the use of the capacitive transistor is they can also use as direct pressure transistors in all those cases where the dielectric constant of the medium changes. The next one is that they were used for measurement of humidity in gases. I give one problem related to capacitive transistors. Okay, here the problem is a capacitive transistor is constructed of two 1-inch two plate separated by 0.01 distance in the air. Calculate the displacement sensitivity of the such area arrangement. The dielectric constant for air is 1.0006. Here it is the problem. In this problem, what given here, the formula is C is equal to, that is capacitive transistors, C is equal to epsilon capital E divided by small d. Okay, here we have calculated the displacement sensitivity. So displacement sensitivity here denoted by capital S, that is we have differentiate of capacitive transistors. So differentiate of the capacitive transistor means once we have differentiate of epsilon into A divided by small d. Okay, here given the problem, what is the value given? First think epsilon. Epsilon is equal to that is the air, that is 1.006. Then A, that is the overlapping here. What is the overlapping here? Two 1 inch two plates. So overlapping is 1 inch. So A is equal to 1. Then distance between the two plate is 0.01 distance in the air. So so D is equal to 0.01. So we have applied the value to the formula. C is equal to epsilon, that is a 0. What is the value here? Epsilon. Here epsilon is, what is the epsilon value here? 1.0006. So we have applied 1.0006 into 1 divided by D. D is equal to 0.01. Okay. Before we have take the differentiate. So in this displacement sensitivity, change the capacitance values. That is 0.225 is the constant. Then epsilon A divided by D, we take the differentiate. So in this differentiate, in the denominator, move to the up. So the power is -1. We take the differentiate means power come to the multiplication. Then the power is reduced by 1. So -1 come to the multiplication -1. Then -1 to the power. So t power -1 -1. Okay. So t power -2. So here the -1 come to the front of the values. So minus 0.225 epsilon A into d power -2. D power -2 means d power -2 come to the denominator. So minus 0.225 into 1.0006 into 1 divided by d value is 0.01 the whole square. You got the idea? Okay. Finally, we get the output is minus 2.25 into 10 power 3 PF into N. Here, power force into impedance. So displacement sensitivity S is equal to minus 2.25 into 10 power 3 PF into N. Okay. Finally, we got the answer of displacement sensitivity.